Alright, so now we're in 7.2. In 7.1, we talked about polygons and their angles, both their sum of the interior and exterior angles. And so in 7.2, we're talking specifically about parallelograms. So let's make sure that we define what a parallelogram is. A parallelogram is a quadrilateral, so a four-sided polygon, right? So a quadrilateral is a quadrilateral with both pairs of opposite sides parallel. Hence a parallelogram, okay? So a parallelogram always has the opposite sides parallel. So that's how you define a parallelogram. Now, parallelograms we'll talk about in another lesson, but a square is a parallelogram because both pairs of opposite sides are parallel. Also, a rectangle is also a parallelogram because both opposite sides are parallel. So that's how you define a parallelogram. That is the definition. Now, to go along with the definition, we have some theorems, okay? So, here we have parallelogram theorems. Okay? Now, the first theorem states that if it's a parallelogram, so if a quadrilateral is a parallelogram, so basically if you have two pairs of opposite sides of a quadrilateral and they are parallel, then the opposite sides are congruent. Okay? So if it's a parallelogram, the opposite sides are congruent. Second theorem states, so this is the first, this is the second parallelogram theorem. The second parallelogram theorem says that if both sides are parallel of the quadrilateral, so if you have a parallelogram, then the opposite angles are congruent. So parallelogram, opposite sides, and opposite angles are congruent. So we're going to do a quick overview of this proof right here. So for this proof, so let's given, let's start with what's given to us. So given, let me draw a figure over here. So I'm going to draw a parallelogram right here. So I need to draw parallel lines. Okay, so here's my parallelogram. I'm going to call this point P, this one point Q, this one R, and this one S. Okay, so given that P, Q, R, S is a parallelogram. That's all we know, is that if this is a parallelogram, which means by definition we know that this and this side is parallel, this side and this side is also parallel. That's the definition, right? So that's what we know. That's what's given to us. And we want to first, I'm going to just prove this theorem, the first theorem, so opposite sides are congruent. We want to prove that QR is parallel with PS and that QP is parallel with RS. Okay, so let's make a two-column proof. So I'll do that right here. So we have our statements and we have our reasons. This one's actually really pretty easy, but first of all, to help us, we want to draw. So let's first, I guess, put what's given. So honestly, I'm just going to put one see given pretty much. I'm too lazy right now to write them, but the given information, which is right here. Reasons that we can state this is that it's given. Okay, so that's pretty much all we have, and what's given is that PQRS is a parallelogram. Sorry, this is our first reason. Okay, so 2, what we're going to actually do is that we are going to draw a line. So this isn't actually part, I guess, really part of the proof, but I'm going to draw a line that connects Q, so I'm going to draw a diagonal. If you remember what a diagonal is a line that connects, or that is drawn from non-consecutive vertices. So I can create 2 triangles here. So here I have 2 different triangles. Okay, and so what I know following from this definition, I know that QR, sorry, I totally wrote these wrong. This should be congruent. We're trying to prove that these are congruent. Now what I know is that QR is parallel with PS, and I know that QP is parallel with RS, and I know this because that's definition of parallelogram. Okay, so that's what I know. Okay, so as you can see here, because I have 2 parallel sides right here, this line acts as a transversal, which means that this angle right here and this angle right here are they are congruent, because these are alternate interior angles. Okay, and then likewise this angle right here is congruent with this angle right here because of alternate interior angles. Okay, so let's write that down. So I know that angle, I'll say PQ, or I'll say RQS. So 3 angle RQS is congruent with angle PSQ, and I know that angle PQS is congruent with RSQ. And I know this because these are alternate interior angles. Okay? Now what I also know is that this line right here, the line QS, is congruent with itself. And I know that because of the reflective property. So I know that QS is congruent with QS, and that's by the reflective property. Okay, and then right here, that means that I have an angle, a side, and an angle, a side, and an angle of 2 different triangles. So that means the 2 triangles are congruent. So I could say 5. I know that triangle PQS is congruent with triangle RSQ by the angle side angle postulate that we covered in the last pre-unit. Now, because these are congruent, these triangles are congruent, then that means that QR is congruent with PS, and that QP is congruent with RS. And this follows from corresponding parts of congruent triangles are congruent. Okay, so there you go. And likewise, you can say the same thing, right? About some of the angles. At least you could say the same thing about these two angles right here. We could say that this angle and this angle are congruent. We have to do just a little bit more proving to prove that these angles right here are congruent, but that wouldn't be too hard to prove, because we know first of all that these are congruent and these are congruent, and so their sums would have to be congruent as well, thus making them the angles congruent. So yeah, so that's pretty much the proof of showing why the sides of a parallelogram, the opposite sides of a parallelogram are congruent. Okay, so now let's move on to these examples here. Okay, so here in example 1, using properties of parallelograms, we want to find the values of x and y. So, finding the values of x and y, let's use what we know about parallelograms. So because this is a parallelogram, and we can tell it's a parallelogram because the opposite sides are parallel, and so that means I know that the sides are congruent to each other. So I know that x plus 4 is equivalent to 12. And then I also know that these opposite angles are congruent. So I know, first of all, I already know that y is equal to 65. Now I just need to solve for x, and I can do that here. I can subtract 4 from both sides, so then x would be equal to 8. So x is equal to 8, y is equal to 65, and there you go. Pretty straightforward. Okay. Alright, now there's two other theorems that we can go through with parallelograms. So here are two additional theorems. So again, parallelogram theorems. And so this one we'll call number 3, number 4. So the third one states that if a quadrilateral is a parallelogram, then its consecutive sides are supplementary. So first of all, we are familiar with this diagram. We've covered it in the last unit. So if we have two parallel lines right here, and we have a line that cuts it called the transversal, then there was what was called consecutive or same-side interior angles. What we knew about same-side interior angles is that they were supplementary. So if I were to draw another line that was parallel with this line, so like kind of like a second transversal, I'll draw that over here, you can see that this quadrilateral is a parallelogram, because by definition of parallelograms, the opposite sides are parallel. So that means that the same side interior angles are supplementary. So that's what this one states pretty much, is that while the opposite angles are congruent, the same side angles are supplementary. So x plus y is equal to 180 degrees. X plus y is equal to 180 degrees. And then here, this theorem states that if a quadrilateral is a parallelogram, then its diagonals bisect each other. Okay, so here is a diagonal. Remember that a diagonal is connecting non-consecutive vertices. So there's one, and then if we were to draw the other optional diagonal, we get two diagonals. Now these diagonals, so this diagonal from Q to S and then this diagonal from P to R right here is the midpoint. So that's pretty much what this theorem states. So bisect, remember that bisect means to pretty much split in, so split into two equal halves. And so that means that this portion of this line and this portion of this line are congruent, and this portion of these lines are also congruent. It does not mean that this line right here is congruent with this line right here. We don't know that. All it's saying is that because it bisects, this is a bisect, because they bisect each other, that means the lines are split into two equal halves. Okay, and that yeah, there you go. That's what these two theorems talk about. So that's pretty much it for this lesson. I know we didn't really cover any example problems here. I might throw up another video showing some example problems or showing more example problems. So make sure you look out for that on the Canvas page. If you have any questions, just be sure to email me.